This is Mrs. O'Neill for AP Chemistry, Chapter 6, Section 1, Electronic Structure of Atoms. Go to page 238 in your textbook and look over those key terms. What happens when someone switches on a neon light? Electrons in the neon atoms are excited to a higher energy by electricity. An electron can remain in a higher energy state only for a very short time, and it emits light when it returns to a lower energy. The resulting glow is explained by one of the most revolutionary discoveries of the 20th century, the quantum theory. So in this section, the wave nature of light, hopefully you'll be able to understand that light, radiant energy, or electromagnetic energy has wave-like properties, and hopefully you can understand its parts, the wavelength, the frequency, and the speed. Again, I suggest to fill in the blanks in your packet and then play to hear my words. So what is light? Light makes up or is part of this electromagnetic radiation or this electromagnetic spectrum. So these waves of electric and magnetic fields are at right angles with each other. So they're going to either emit or absorb by substances. So they're going to either emit by the substance or absorb by the substance. And what we really see is the light, the visible light, the Roy G. Biv, the rainbow. So what are the parts of the wave? Well, wavelength is with this lambda symbol, and it just means it's the distance between two adjacent peaks or troughs. So the peaks are at the top, the troughs are on the bottom. So you can either do wavelength again from the two peaks or two troughs, but it's a length, but it's a wavelength because we're talking about a wave. So from here to here is basically one wave, and that one wave has a length of, boom, from a peak to a peak, or you can do trough to a trough. Okay, so parts of the wave continued. Frequency, again, it looks like a V like velocity, but it really is a nu. It's called a Greek symbol of nu. So it's how many times a wavelength can go through a particular cycle or a given point. So that's why it actually has two units. One is called the hertz, but you don't see that as often as actually per second, or s to the -1, because that's really the true unit that you're going to be able to use to cancel out when you're dealing with the speed of light and the equations. So here we have three different frequencies. We have low frequency, so if all three waves are in a particular cycle, here we have low frequency because there's not that many waves, and on the bottom we have high frequency because we have a lot of waves. So in your packet, you should draw these waves and show how wavelength and frequency are inversely related to each other. So here we have, if we have a long wavelength, we're going to have low frequency, right? Not as many waves can go through that cycle if they're long. However, if we have a short wavelength, we're going to have high frequency. So a lot of waves are going to be able to get through that cycle. So they're opposite of each other. Long wavelength, low frequency; short wavelength, high frequency. So there are many kinds of this electromagnetic waves, and they have different wavelengths and frequency. So it goes from gamma to radio, or I like to say radio to gamma, because then it's Roy G. Biv, then it's red to the purple. So here's our speed of light, and we need to know this. It's a symbol of C. We need to know this because it's in an equation. The speed of light really equals our wavelength times our frequency. So again, lambda times nu. So read over this and see if you can come up with an answer. Good. See you in class.